So in this section here, we'll probably spend the bulk of 3 to 4 days, to be honest with you, without even trying too hard. It takes a little bit of time to go through this. Traditionally, you won't like this, unless you like puzzles.
Oh, no.
What kind of puzzles?
Logic puzzles.
Oh, we're not in trouble.
I like
Okay.
pieces.
So here's what I know. We know that cosine, sine, and tangent all have inverse functions. We know that they have reciprocal properties. What's the reciprocal property of cosine? Secant. So cosine has an inverse that's equal to 1 over secant. I can flip them back and forth, which means 1 over cosine is secant. Are you okay without me putting the x there? Cosine x, sine x, tangent x, secant x, all that. Is that okay?
Yeah.
I know this works. What's the reciprocal one with sine? Cosecant. So I know that sine equals 1 over cosecant, or 1 over sine, is cosecant. Just by using reciprocal properties. Tangent has the reciprocal property of cotangent. Same deal. Tangent would equal 1 over cotangent, or cotangent, 1 over tangent equals cotangent. Exciting. What does tangent equal though? Good. Y over x, otherwise known as? We also know, yeah, that tangent, which means cotangent is cosine of sine. All right. That's a start.
Yep.
We also have to deal with what are called Pythagorean identities. And I have all of this. We just wrote out these 3. The reciprocals. We know that tangent and cotangent are those. We now have what are called Pythagorean identities. And this goes into some of those problems in 14.4 that we saw where they had cosine mixed with the sine, how they were mixed together. Well, we're going to be able to do a lot of substitution via using these, the Pythagorean identities. Pythagorean identities basically are sine squared plus cosine squared equals 1. 1 plus tangent squared equals secant squared. And 1 plus cotangent squared is cosecant squared. The reason that we have all these properties and things that we're going to look at is so that we can take trig statements and simplify them or verify them. I made a handy dandy little sheet of this exact same thing. I was trying my best to count. Mm-hmm. Now, one of the things that I wanted to show you guys with these Pythagorean identities is that you can rewrite them and solve for each individual part. For example, if I'm looking at the sine squared plus cosine squared equals 1, if I want to get sine squared, I just leave it there. Well, I knew we have spares, not a big deal. If I want to get sine squared by itself, what would I move? Cosine squared. So basically what I can say then is, this also works. That sine squared equals 1 minus cosine squared. So that when we get to an equation later on, where we have cosine of x times sine squared of x minus 1 equals 0, we'll be able to solve this equation because we can substitute in for sine squared and rewrite it as cosines and so on. All right. there's a lot of these little tricks that we're going to be doing. If I want to get cosine by itself, what would I do? Exactly. So there's different versions of all of these. These Pythagorean identities allow you to do this. Okay? It allows you to do this. If you think about it in terms of unit circle, opposites and adjacents, if you put theta, isn't your opposite is your sine, your adjacent is your cosine, and it creates a right triangle. Change in y plus change in x is your r. What's your radius in a unit circle? 1. That's how this works. It all synergistically exists. I have made that up. I don't think it's real. Same deal with tangent. If I want to get tangent squared by itself, what could I do? Subtract 1. So I can say that tangent squared is secant squared minus 1. I could also say 1 is equal to secant squared minus tangent squared, but you don't see that very often. You don't see that very often. And the last one with the cotangent. If I want to get cotangent by itself, what would I do? Same deal, subtract 1. Now there's other properties, there's other identities that we look at. There's the cofunction identities and there's the negative identities that we generally don't bother with them at all in Algebra 2. Even in the honors class, we don't bother with them. We do that stuff in pre-calc. There's no reason for us to worry about the cofunction identities in Algebra 2. There really isn't. So if you look in your book in 14.4, you'll see that there are a few more of the properties. There's like 6 more, 8. But these are what we're looking at. Which allows me to do the following equations. We can do stuff like this. I don't know how well you can see that, and I know it might be kind of inappropriate nowadays, but the sine of b divided by the tangent of b equals cos b, which would be the cosine of b. You can simplify and verify. Get it? Cos b?
I got it.
I get it.
So what happens now, we have things that are called simplify.
Is that us or verse?
Versus.
I'm going to be simplified us there.
I don't know. It looks like you.
We're going to be looking at here are two different style of problems. A simplify versus verify. You just keep going until you can stop. Verify, it tells you what you'll get. Basically, verify has an equal sign. That's the only difference. It tells you what your answer will be after you simplify. Simplify doesn't tell you when you're done. Verify does. That's the only difference between the two. So if I look back at that, the Cosby joke, we take the sine of b divided by the tangent of b. They want you to verify that it equals the cosine of b, the Cosby. Get the pudding pop. Sorry. Thank you for seeing that. That was awesome.
Bet you almost dropped the pen.
Twice. So here's what we do. We take this, knowing that we have a whole bunch of junk on the left-hand side, and you want it to look like the right-hand side. Usually, you're moving from left to right. The general rule of thumb with these types of problems is you find the one that looks more complicated, and that's the stuff you're going to simplify. Yes, sir?
Why are sine and cosine like first letters are capital, but left tangent is not?
I don't know. I don't know. I have no idea. All right, very good. So, here's what happens. Does everybody agree that sine divided by tangent can be rewritten like this?
Yeah.
Everybody okay with that? What is 1 over tangent equal to? Cotangent, very good. Which means I can go to the next step. And what does cotangent simplify to be?
Sine over cosine.
Cosine over,
What? Oh, cosine, yeah, cosine over.
so this becomes sine over 1 times cosine over sine. And what simplifies?
Sine.
Sines. And there's your answer.
That's it?
That's it.
Cosine?
Yeah, because it simplifies. What you're doing here is you're saying the sine of something divided by the tangent of something is going to equal the cosine of that something. Okay? Again, is it okay that I'm not writing the theta, the b, the x, or anything like that? It's fine. As long as they are the same theta, it always works. Don't worry, we're not going to trick you and throw one at you that has different theta values, or like an x and a y. You don't have to worry about that. Yes, sir?
Where did the cotangent?
Where did the cotangent come in? 1 over tangent. Right here.
Yeah, but does it?
What we're doing is just using a bunch of different properties, the reciprocals, and we're just rewriting things as they go through. Okay? Sorry. Let's try another one. Simplify. Cotangent times secant. We'll come back to this one in a second. Notice the difference here. There's no equal sign. There's no equal sign, so it doesn't tell you when you're done. So, suggestion, whenever you have reciprocal properties, in this case, cotangent and secant, try to rewrite them in terms of sines and cosines. That's usually a very good first step. Always to try to rewrite the sine and cosine, because you know if you get them with fractions, they will simplify diagonally when you're multiplying. Okay. Yes, and secant of x, yeah. And that's one of the reasons why I don't write out that value of x after, because it gets muddy. It gets messy. So think about cotangent. Cotangent in terms of sines and cosines is 1 over what? 1 over tangent. Or I can write it, if I want to write in terms of sine and cosine, what's cotangent? Cosine over sine. So I'm going to go right to cosine over sine. Secant is a reciprocal property. The reciprocal property of what? Cosine. So secant can be rewritten as 1 over cosine. What happens? Cosines drop. Is the sine wearing a life jacket?
No?
No. So your answer is still going to be 1 over sine, which is cosecant.
Hold on.
The reason why I asked if sine is wearing a life jacket because it's in a denominator. It doesn't float up automatically because it's not wearing a flotation device.
It's not jumping the point.
Yes, it's not.
It wasn't very punny.
You can't swing.
Okay. So you just becomes 1 over sine. You get cosecant. Can you go any further than that?
No.
You're done.
It's one of these things.
Okay.
I don't know which one I like more.
Sine times the quantity 1 plus cotangent squared. As soon as I see a square, I'm always going to refer back real quick to my Pythagorean identities on my list. Does 1 plus cotangent squared equal anything?
Yes.
It equals what? It equals cosecant squared. Everybody see that?
Yeah.
So I'm going to rewrite 1 plus cotangent squared as cosecant squared. So I get sine times cosecant squared. Cosecant squared is the reciprocal property of what? sine. It's cosecant squared would be 1 over sine squared. What simplifies? How many?
One.
Only 1. So the numerator sine goes away, and 1 of these go away, and you're left with 1 over sine, which is known as cosecant. Very good. Simplify, verify. Simplify just means go until you can stop. Verify means it's going to give you the answer. Yes, sir?
For the one you did right before this one, for the cotangent, how do you know it's cosine over sine?
Cotangent is the reciprocal property of tangent.
Yeah.
So if tangent is sine over cosine, the reciprocal of that would be cosine over sine.
Oh, okay.
Yeah.
When we're tested on this, I'm gonna
Probably not. At first, maybe. Well, that's why we spent a few days on it. And believe it or not, once you get going on these things, there's only so many of them you can do. And then all you wind up doing is just they change the order, and that's it. Okay? Okay.
So you can like add numbers to this or something?
What do you mean?
Like sine, 30, you like add numbers to this.
The only way this is going to work is if this was that's the only way this would work.
If they were.
They'd have to be the same because then you would simplify it out that this is still going to equal that in the end. That theta value has to remain consistent in order for the properties to work. We're not so much using anything, we're just simplify verifying here today because when we get back to 14.4, we're going to go to this problem here and be able to solve it by using some of the properties to rewrite it as a single value.
So if it was like sine x plus tangent squared y, then you
Correct. Correct. So you don't need to worry about that. That's why I would say that this theta value, I don't even write it in half the time because of the idea that it doesn't matter because it's always going to be consistent to make the property work. Plus it's cleaner. Negative angle, we don't have to worry about this. Again, verify. Cosine times secant equals 1. Let's verify that that works. Well, there's a couple of ways to do that. Nope, you can't. Why bother? You're making it more difficult on yourself. Because what is secant? 1 over cosine, isn't it? Rewrite it. Cosine times 1 over cosine. What simplifies? What are you left with?
Okay. 1.
Okay?
Is that it?
Yes.
That's it.
Yeah, you verified that if you take cosine, you multiply by its reciprocal, you're going to get 1. Because what's 2 times its reciprocal? What's 3 times its reciprocal? 1. What's potato times potato's reciprocal? 1. It's convenient.
Well, what's the different size potatoes?
But it's the, you're, okay, can't do that because potato to its reciprocal. So it has to be of that specific potato. Ooh, yeah! All right. He thought he was so smug on that one. We're doing different sized potatoes. I'm messing with you, Tangent, cosecant, cosine. All of that multiplied together is going to equal 1. Well, how? Again, when you see multiple trig functions, try to rewrite them as sines and cosines, especially when they're not squared. So tangent is what over what? Sine over cosine. Cosecant is the reciprocal property of 1 over sine. Cosine is, well, just cosine. What happens?
Is it always going to be 1?
No.
What do you do?
Then you goofed. You done goofed. Go back and figure it out. That's the idea with verify. They're telling you what it's going to equal in the end.
I like verify a lot.
I don't like this way from.
Usually people like the other one better, believe it or not. Because when they start to get a little bit more complicated, which they will, you start to start second guessing yourself. Oh wait, how's that going to work? Oh, happens all the time. For example, let's take cotangent squared over cosecant and show that it's going to equal cosecant minus sine. Couple things come into play here. A couple of different things are going to come into play. One of which is, notice how you're going from a monomial, things all put together by multiplication, into two terms, something with a subtraction. That means when you're subtracting with fractions, you had it at some point in time, get yourself a common denominator. Do you agree on that? Now, the other thing is notice that you have this cotangent squared. Is cotangent squared, does it have Pythagorean identity? Cotangent squared is what? Secant squared plus 1 or is it secant squared minus 1?
Minus 1.
Minus 1. So, right there, I'm going to take this cotangent squared and rewrite it as its Pythagorean. So I get 1 minus secant squared over cosecant. Oh, I'm sorry, it's cosecant, excuse me. Yeah, that's what I thought. I'm sorry. Yes, sir. What, Nick?
Why can you do that if there's no like plus one, or like 1 plus doesn't have to have a plus one?
Well, no, because what I'm saying is that when you have, I have it backwards, don't I? What happens here is when you have cotangent squared, it's 1 plus cotangent squared is cosecant squared. So if I want to isolate cotangent, I subtract the 1. So I get cosecant squared minus 1. I'm rewriting it. Now, how many terms are in the numerator? How many terms are in the denominator? Split apart the fraction. That's how you have a common denominator now. You have a cosecant squared over a cosecant minus 1 over cosecant. If you have 1 in the denominator, multiple up top, split it out, because that right there is telling you you've got yourself a common denominator. It's a nice little trick to remember. What does cosecant squared over cosecant simplify to be? Cosecant. What's 1 over cosecant? Sine. Done. Pythagorean, split it apart, simplify.
What about that second half of the equation?
Which part?
Never mind.
Okay.
So why, how does cosine work? This isn't it?
See how there's 2 over 1?
Yeah.
Let's think of this as x squared over x. What do you get?
1 over, but once you take what the x.
The other cosecant here?
Yeah.
That's the reciprocal property. 1 over cosecant is sine.
Oh.
Okay? That's the idea when you have the sine is 1 over cosecant, cosecant is 1 over sine. Oh, you're gonna love this.
What am
You've done this trick many, many times.
Oh, you flipping. Which is flipping 4.
What?
4.
Oh.
Is that, was that, is that,
It's
oh,
the
oh.
multiplying times
What would you multiply to get rid of the I in the denominator?
2 plus 5.
2 plus I. You do that, right? Okay. What would you do if it was this?
Really bringing back eyes right
plus root 2. You multiply by the conjugate.
So multiply by 1 plus
Is that what we're gonna do for one?
Because here, remember each time you did that, what were you creating?
Zero
What?
or one. You're canceling
Not
out.
common denominator, you're creating a perfect square.
Oh,
We're
Yeah.
creating a difference of squares in the denominator. Alright? It doesn't change with trig. So if I go back to where we're at now, if I go sine over 1 minus cosine, what can I multiply top and bottom by?
1 plus.
1 plus cosine. Because when I FOIL that out in the denominator, it's still a difference of squares. First term squared minus last term squared. You multiply it out, you get 1 plus cosine minus cosine squared. The middle terms drop. That was the whole trick, always by multiplying by conjugates. You create a difference of squares. First term squared minus second term squared. Works all the time. Yeah, Cody?
Is there ever gonna be like a situation where it won't equal?
What do you mean?
Like, if you do it all right, you simplify it out, and it won't equal the other one?
Oh, it has to. It's telling you it will. I don't think there's that many typos.
No, like it's
Oh, it's something that you can't simplify?
Yeah, it's like unsolved.
I don't think so.
It's no.
Yeah.
I don't believe there's any of those. I'm pretty sure I give you, if it's gonna be an answer, you're gonna get an answer.
Okay.
Okay.
Got it.
So now, I'm at the point where I have this. I'm at this here. Everybody okay? Ye- What is 1 minus cosine squared simplified to be? Sine squared, very good. What drops?
Design.
1 sine.
If you cross multiply, you get one of the Pythagorean identities.
Correct. Don't cross multiply. When you're doing these things, even though it says you have a fraction equal fraction, you should get, when you multiply through, you should get a true answer. You should get some sort of Pythagorean or whatever. But in these cases, it's just saying they want you to simplify one side to make it equal to the other side. Okay, does that make sense? You don't need to do the cross multiply from here. Notice how then the signs drop through, and I'm left with just what they wanted me to get to. 1 plus the cosine over sine.
I don't like this one.
It's logic. It's logic. Okay. Simplify.
All right, that's good.
Secant plus 1, secant minus 1, all over tangent. Secant plus 1, secant minus 1, all over tangent. Well, that's telling you to do what in the numerator, you think?
Multiply. Foil.
FOIL it, yeah, exactly. So if I go to FOIL that out, what do you get in the numerator? Secant squared minus 1. Is secant squared minus 1 a Pythagorean problem? What is it? Tangent's very good. So you get tangent squared over tangent, otherwise known as tangent. Yes. It can wind up being secant, because if you wind up with 1 over cosine, you can rewrite that as secant. Yeah, that's what you would do. Or if you wind up with 1 over secant, just write it as cosine.
That one.
So we don't have to put the X?
No, it's okay. Because it's always gonna be the same for both of them, so it's not a big deal. What do you get?
One?
What's the?
Oh, yeah.
What?
And there's a lot of that happens, the overlook of the obvious. Could you go long form on this one? Get common denominators and try to work itself through? Absolutely, it works. You could write this as 1 over cosine squared minus sine squared over cosine squared. Do you have a common denominator? Yeah. So isn't that's the same as 1 minus sine squared over cosine squared? What's 1 minus sine squared? Cosine squared.
I don't know this yet.
Works the same way. There are multiple ways to do this. Some of them are a lot easier than others. Some of them are going to take 3 steps. Some of them might take 8. What's wrong? I think I have a more difficult one. We've done all these. No, I don't want to get to this one yet. All right. I wasn't even trying to flip and I dropped it. I'll give you a few of these to try tonight. It's going to take a couple days to get accustomed to this. I'm not going to lie, this is a little tricky.
You got baseball?
What?
It's Saturday, I think it's Saturday.
They like
They better not give me bonuses and be like, go sell cards after everyone sells cards. That better not happen. Is anyone here want to buy a card? What?
Mr. Murphy?
Go buy a card? If he says I can sell 5, I'd be fine with that.
Yeah, 'cause you could.
Let's see here. We're going to start.
Yeah, you buy a card? You're like, sure. And then
There isn't really much to be
I'll buy it.
Oh, you should have
But
See how there's the oral, the top, the middle part here? Start on the bottom where it says written exercises. Let's try this. Let's go 2 through. I know, Cole's got a rule, so I just want to do this real quick, see if I can get some of these in. 2 through 40, every other even. So every 4th. Wait, that doesn't work. We start at 4 then, right?
I don't know. What we're gonna do.
All right, we'll do 4 through 44 every.
Every other even.
every other
Try that for now.
Okay.
And I'll get. Yep. And that's a good chunk of simplify, verify, as well as we get into the more complex one where we have to start dealing with common denominators and whatnot.
Here we go.
The property. The property is.
They really want you to sign, huh?
Yeah, I know.
Don't be jealous.
Well, I might have to.
Why?
They might move on to somebody else. That's how the game works.
Will we do 32? Since these are crossed out, would you count these still? Or we do 34?
There's no reason. You're just using, you're just using some direct substitution off of these. We don't have to use this directly here. It's knowing the theory, it's the identities. Once you learn those, you get those kind of
lot better.
Alicia, what do you want?
Well, you crossed off a section, so do you want to?